Hi everyone. We are going to be wrapping up chapter 36, which is on population density. So something that we've talked about with the growth models is that under the logistic growth model, which is the most representative of almost all species, we have a plateauing off, and that's because as population densities increase, there is a decrease in the population growth. And so right here, you can actually see that even with the human population, which looks exponential, if you look at the growth rate is decreasing. And so the reason for this decrease in growth rate is because there is a slowing down in birth rates and an increase in death rates as the population gets more and more dense. So there are different reasons why there's a decrease in births and an increase in deaths. The most important is density-dependent factors, and these are limiting factors whose intensity depends on the population density. So that pretty much means that as density increases, these factors become more and more relevant. One important one is called intraspecific competition. Intraspecific competition is the competition between individuals within the same species for limited resources. And so it makes sense that as there are more individuals, there's more fierce competition leading to different factors such as slower birth rate. And part of that is because when you're competing, there's less energy for reproduction. But there's also a biological factor here where they've done study on mice. And if you increase the density, the body starts to secrete a hormone that actually reduces the fertility of those rats. And so biologically, you're less likely to give birth when you are in a very densely populated area. There's also an increase in death rates, and so part of that's just competing. There may not be enough resources to go around, but it's also because there's also a biological factor here as well, in which there are chemicals released in the body that actually inhibit your immune system due to the stress of living with so many other species. So these are all dependent on the density of the population, and this is something that keeps the population in check from growing too much. There's also something called density-independent factors. These density-independent factors are just things that limit the population but have nothing to do with the actual population size and could affect the population regardless of its growth. And the way you can determine this, what's characteristic of it, you'll see as the population is growing, there will be this sudden downturn, a very sharp decrease. For the density-dependent factors, you'll see the logarithmic growth, where it'll start to plateau off. Here, instead of plateauing off nicely, the population number actually declines rapidly. And usually this is something dramatic and external, like weather, dramatic changes to the shelter, abiotic factors. So any of those things due to shelter or whatever, maybe all the food sources suddenly wiped out, and it has nothing to do with the actual size of the population. So these also they also limit the population growth. Okay. Some populations naturally have what are called boom and bust cycles. And so that means that they don't really have a stable population size. They regularly have this fluctuation where there'll be an increase in population size, then a decrease, and then it'll increase again, et cetera, et cetera. And so booms are when there's a rapid exponential growth, and bust is when you have a decrease in the population. Here's a graph from the textbook, and it shows the boom and bust cycle of the snowshoe hare, which is this white rabbit, and the lynx, which is its predator. And so you can see that the snowshoe hare fluctuates very rapidly, and then the lynx actually its fluctuations follow the snowshoe hare. And so when the population of the snowshoe hare, which is its main food source, starts to decline, you see there's a correlating decline with the lynx. It's easier seen in this peak right here where there starts to be a rapid decrease, and that changes to a decrease in the lynx. So that makes sense, but the question is, well, why does the hare decrease in the first place? Why does the hare fluctuate? And it makes sense why the lynx would follow it. There are different hypotheses, but the main idea here is that the lynx fluctuates just due to the natural density dependent factors. So a combination of making sure there's enough food source and predation. So when the hares get too much, they tend to rapidly reproduce and have many, many children. But when it hits past kind of like its natural set point, past what the environment can sustain, there'll be a lot of other predators other than the lynx that will start to eat it because there's so many of them. And there will also be a less food source that may be available. The predator factor is much more important, but both of these are come into play, which leads to a decrease in the hares. But then once it hits kind of like a bottom, now there's not as many predators to find them because there's less of the hares, and there might be more food now available, and so it'll increase. So there's this cycling. Okay, last topics on human population. And so as discussed before, there is pretty much an exponential growth in the human population. This is projected out. We're expecting perhaps it will plateau out. But yeah, so far we've only seen an exponential growth. But we've also seen that even though it looks like we keep on increasing the world's population, the amount that it's increasing has been decreasing over time. So these increments show that every year the amount of change, the increment is lower. And so that will affect, that kind of actually does show that it's more logarithmic than we think it is. So there's something called demographic transition, and this is something we see with a lot of developed nations. This is when you shift from having high birth and death rates that are both kind of high, but roughly equal, and then it kind of leads to, over time, having roughly equal death and birth rates, but they're both kind of low. And so in the past, in the early part of human history, little r was very small, the growth rate of the human population growth rate. And that's because we had a lot of children, but we also had a really high mortality rate. So we had a lot of births, but a lot of deaths, and they ended up canceling out so that overall there wasn't very much population growth. What happened over time is that our birth rate was generally stayed like roughly the same for some time, but then our death rate actually decreased. And so by doing that, we've actually increased the overall human population. But as a nation becomes more and more densely populated and developed, our birth rate also starts to decline to the point where it eventually meets our death rate. And so we also get back to that state of not really increasing our population size very much. So with Sweden, we can actually see this directly. With Mexico right now, the birth rate is still much higher than death rate, but they project into the future, which your textbook shows, that they think that these two lines will also meet in the middle, start to meet in the same way that Sweden has. Age structures. And so age structures are a good way to kind of analyze why there's an increase in population. So age structures just tell you the number of individuals in a different age group. So these are all the different, sorry, it's a little bit blurry, but the side is male, the side is female. This is the age structure for Mexico at different points in time. This is in the 1989, this one's 2005, and then this one is 2035, so this is what they project for the future. And so you can see that that this pink area is the number of people who are reproductively active. So these are the people in the population that can have children, especially the female section. And so the way you can tell whether or not a population is growing is by comparing the older females with the number of reproductive females in the next generation. And you can see that we're increasing over time. And so it just goes to show that once you start off with having a mother has a much higher fertility rate. That means that the average number of children produced by the woman over her lifetime is much higher than her and her own partner, so more than two. Pretty much she's more than replacing herself and her spouse. Then you're going to have a population increase. This leads to something called population momentum. And this is when you just have a rapid population expansion, and that's due to the increase in proportion of women who can have children in the population. And so we see this population momentum where we have an increasing number of women each generation that are able to have children. All right, thank you guys so much for watching. Bye.